Okay, so this point is called the center of a circle. This is called the radius, right? So the OA will be radius. If I draw exactly one opposite radius, that makes a, what will this become?
Diameter.
Diameter. How many radii
Diameter.
can we, correct, how many radii can we draw in a circle?
Infinite.
Okay, how many diameters we can draw in a circle?
Infinite.
Correct. What is this green part called? Oh, I'm just trying to use the green color, but somehow I'm unable to. So what is the boundary of the circle called? Yeah. What is the boundary of the circle called? It starts from C. Circumference, right? Yes. The boundary of a circle is called circumference. What is the
Circum.
space? Circumference, yes. What is the space inside the circle called? If you want to find out the space inside a circle, what is it called?
Area.
Area. Perfect, right? Okay.
Volume.
No, area. Circle is a two-dimensional shape. In two-dimensional shape, we always get area, not volume. Volume we always get in three-dimensional shape. Okay. So that is area, and the boundary was circumference, right? Diameter, radius, and center. Very clear, Manya?
Yes.
Okay. Now, if I take a part of a circumference of a circle, what is that called? We had done this yesterday.
Minor arc.
Very good. Okay, that is called arc, but that is also called minor arc. Perfect. And what will be the other part called, which you have already answered now, but yeah, let me use another color to just make it different. So what will be this called? The
Major arc.
major arc. Very good. So minor arc and major arc, very clear, I can see. Next, if I just draw a radius with the minor arc, so you get one area, which is this. What is this area called?
A minor segment.
Segment. Yeah, sure. Will it be segment or will it be called something else?
Something else.
Something else. What is it called? It will be called minor sector, right?
Yes.
Minor sector. So what is minor sector? Minor sector is the space between the two radii and a minor arc, right? So
Yes.
what will be this called?
Major sector.
Very good. So what is major sector? The space between the two radii, again the same radii, O, let's say OM and ON, and the major arc MN, right? So that will be nothing but your major sector. Okay. Now let's go to the next part. So minor arc, minor sector, major sector is very clear. We are just revising it. Of course, we had done it already. So let's go to the next part now. So for that, I'm drawing a circle again. And in this circle, oh, it has not taken, yes. Next, I am drawing a line segment passing from any 2 points from the circumference of a circle. What is this called?
Chord.
Chord. Very good. Now you can see that there are two spaces you can see because of this chord. The smaller space, which is nothing but the area between the chord and a minor arc only, you would say, because of course this is a minor arc. AB is a minor arc and AB, the other part will be the major arc. So this part will be called as, what is it called? Now it will be called what you had answered,
Minor segment.
minor segment. Very good. And there is another space also which you can see. What
Major
is this called?
segment.
Major segment. I think it's very clear. Okay. Can you also tell me that if I draw the longest chord in this circle, that is also called something else? Major segment. Yes, my question is, if you draw the longest chord in a circle, don't you think, Manya, that if you draw one chord which will pass through the center of a circle, that is going to be the longest chord? Yes or no? Right? And
Yes.
that longest chord which will pass through the center of a circle is also called, we discussed it in the start of the class, diameter. Correct? So remember
Yes.
these small things. What is the longest chord in a circle? That is called a
And
diameter. So you can also say, Manya, that all the chords are diameter, but all the diameters, sorry, all the, not all the chords, all the diameters are chord, but all the chords are not diameter. For example, of course, this is a chord, but is this a diameter of a circle? Of course not, but this is a chord. So all the diameters will be chord, but all the chords will not be a diameter. Clear? Understood this?
yes.
Okay. Next is we had understood about non-intersecting line, secant, and tangent. You remember that, Manu?
Yes.
Okay. Let's check. So you have a circle, and if you'll have a line which will not touch the circle, so that will be called as non-intersecting line, right? But if you have a circle and there is a line which is passing through 2 points of a circle and it is a line, so of course it will go endlessly, there is no break, like there is no stop. So what will be this line called? This line is called secant, right?
Second.
Correct, secant. And there is another line which will pass through the circle but not from 2 points, only from 1 point. And what will be that called? Let's see. So for example, if I draw, a line like this, right? So it is touching the circle at just 1 point. So this will be called as a tangent. Even if you want to extend it, you can extend it. If you want to start from here only, you can start from here also. But this will be called tangent. Do you see the difference between tangent and secant? Secant is passing the circle at 2 points, but tangent is, crossing through the circle or passing through the circle at only 1 point, and which is this point. Clear, Manya? Now this is
Yes.
also called, I forgot to tell you yesterday. This point where the tangent touches the circle, this point, this is the only 1 point, of course, and this point is called point of contact. What is this called? It is called point of contact. I think the very basic things are clear, Manya, right? Yes.
Yes.
Okay, there were other things also we had done, that if we have the center of a circle and if you draw the radius on the tangent, that will always be perpendicular, right? That is also we had done in the last class. If there is 1 point outside the circle and through this point, if you draw a tangent, of course, it will pass through the circle. If you draw a tangent, for example, you have a point here, so one tangent and another tangent, then the length will be same. This length from here to here and to here, the length are going to be the same. I'll make you understand this, like more, like you will be understanding this more properly if I show you the question based on this. So for that, let's go to the question. So today we'll be covering exercise 10.1. Okay. So of course, what I was talking about, you can see here, right, Manya?
Yes.
So you can see in figure 10.1, the line PQ, figure 10.1, the first one. The PQ and the circle have no common point. In this case, PQ is called a non-intersecting line, right? Whereas the other case, there are two common points that the line PQ and the circle have. Sorry, there are two common points A and B that the line PQ and the circle have. In this case, we call this as a secant, and the third one where the line touches the circle at only 1 point is called a tangent. Clear? That is what we have discussed just now. Okay, now let us not go to all these things. Let us quickly go to the question. Now, see, this is a very important line. Of course, you can understand it. A tangent to a circle is a line that intersects the circle at only one point. This is what I said already. Correct? Do you understand this point, Manya?
Yes.
Yes, because that is what we discussed already. Next, of course, here you can see that there will be only one tangent at a point of a circle. Okay, let's go to the question. Also, you can notice one thing that you should be knowing one more thing, that if you notice that if you draw one tangent, for example, this is one tangent, right? All these are tangent, Manya. Are these all tangent?
Yes.
Except this one and this one. Are these all tangent or something else?
Tangent.
They are called secant, right? Because see, they are all passing through 2 points. Yes or no? The
Yes.
only line which is passing through one point is this line and this line, and these are the only two which are called tangents. The other are all called secants. Now, can you notice one thing, that if you draw one tangent on a circle, then there will be one parallel tangent you can draw. Is it possible that from this line, Manya, except this tangent, you can draw any other tangent which will be parallel? No, not possible. Maybe you can draw a tangent like this, but then this and this will be parallel. Of course not. So for one tangent, there is one more tangent you can draw which will be parallel to that tangent. Not more than that. Correct? Understood this point?
Yes.
Yes? Okay. So this is of course point of contact. What is point of contact? The common point of the tangent and the circle. Where the tangent and the circle meet, that is called the point of contact. Okay. So this is what I already explained you. The tangent at any point of a circle is perpendicular to the radius through the point of contact, right? See, if this is a tangent in a circle and this is the radius, of course you can see that this is going to be 90 degrees. Got it, Manya? This is a very important theorem. We are not going to understand the proof and everything right now. Just remember this property, and we are going to use this property in a lot of questions. Okay. So we have our first question, but before that, can you just read the remarks here that is written?
By theorem above, we can also conclude that at any point on a circle there can be one and only
One
one
tangent. So
tangent.
do you understand this? That if you have a circle, and if in this circle, like if on this circle you take any point, with from that point, Manya, it is not possible that you can draw two tangents. Passing through this point, it is only possible to make one tangent, not more than that. You can take any other point, then you can make a tangent. But at that particular point, no other tangents you can draw. Clear?
Yes.
Okay, now let us do exercise 10.1. So can you just read the first question and can you give me the answer on your own? How many tangents can a circle have? Answer. How many tangents can a circle have?
Two.
Okay, two will be parallel. Okay, two pairs will be parallel. Like, see, I'm not saying, Manya, that only two parallel will be parallel. If you draw one tangent, then through this tangent, only one parallel you can draw. For example, suppose you draw the tangent here, then through this also only one parallel. Are you understanding? Suppose you are drawing a tangent here. Through this tangent, only one parallel. Are you understanding that through one tangent, there is one more tangent possible which will be parallel to that? But in that way, how many tangents can you draw? Do you notice one thing? How many tangents? How
One.
many tangents? Infinitely many. Do you understand this? Here they're not asking you, Manya, that how many parallel tangents can a circle have. So set of parallel, that will also become infinitely many only. For one tangent, there will be one more tangent. So maximum two tangents would be parallel to each other. right? I hope you are understanding what I'm saying.
Yes.
Yes, but in general, how many tangents can a circle have? Infinitely many. Okay, next, fill in the blanks. This is done. A tangent to a circle, okay, a tangent to a circle intersects it in dash point. How many points? The question says, let me try it again. The question says a tangent to a circle. Suppose you have a circle. So a tangent to a circle intersect. This tangent is intersecting the circle at how many points, Manya?
1.
One. That is the answer. 1 point. See, just by understanding the concept, Manya, you will be able to answer all the questions here. Okay. Next, a line intersecting a circle in 2 points is called what? You have a circle and it is saying a line intersecting the circle at 2 points. What will be this line called? Yes, Manya. This is called tangent, right? Because it is touching the circle at 1 point. The line which touches the circle at 2 points, we did it in today's class also. Starts from S. Is it not secant? Yes, Manya.
Sec.
Do you agree? Secant will be the answer? Yes or no?
Yes.
We did it here also on the when we revised the circle concept. Did we not revise secant also? What is secant? Of course, the secant is the line that touches the circle at 2 points. See, here is the answer. Can you see this?
Yes.
Yeah, very clear, no doubt, right? Okay, so let's come to this. So, how many tangents can a circle have? Of course, infinitely many. A tangent to a circle intersects it in how many points? Of course, only 1 point. A line intersecting a circle in 2 points is called, of course, a secant. What is the answer for the third one? A circle can have dash parallel tangents at the most. Two, two parallel tangents, do you agree?
Yes.
Manya, if I write down 2 here, do you agree? Because if I draw a circle and if I draw one tangent here, then parallel to this tangent is only one that is possible. If I'm talking about just this one, right? So how many parallel tangents you can draw? 2. Can we have more than 2 parallel tangents? Like there is another line that you are drawing, which will also be the parallel to this one? Of course not. So there cannot be more than 2. So therefore, a circle can have 2 parallel tangents at the most. Understood this?
Yes.
Yes. So all the fill in the blanks should be very clear, Manya. If you are having any doubt, you can ask me. Okay. Let's go to the next question. The common point of a tangent to a circle and the circle is called. So there is a circle. The common point of a tangent, of course, this is a tangent. So the common point, that means this point of a tangent to a circle and the circle is called, what is this point called? I told you today only. And I said that I had forgotten to inform you this in the last class. What is this called? It is called point of contact, right?
Okay.
Yes. So you have understood all the fill in the blanks, or do you have any doubt?
No doubt.
Understood, right? These are the concepts that, of course, you can remember, or you can just take a screenshot also and you can have a look at it. Let's go to the next question, Manya. But for the next question, I'll be copying the question and I'll take you to the whiteboard so that we can do this question very properly. In fact, I'll take both the questions. So let's go to another screen now. Okay, I hope you can see my shared screen. And our questions are here. So, would you like to read the third question? Yes. Can you read the
A
third question?
tangent PQ at point P of a circle of a radius 5 cm meets a line through the center O at a point Q so that OQ equal 12 cm length. PQ is first 12 cm, second 3rd centimeter,
So
fourth.
these are the options, and you have to choose the correct option. Right?
Okay.
So there is a circle, of course. They're talking about tangents, of course, we will have a circle. So a tangent PQ at a point P. So that means there is a point P. Let me change the color. Suppose there is a point P and a tangent PQ. Okay, and a tangent PQ. For example, this is the tangent at a point P, and this is Q, of a circle of radius 5 centimeters. The radius is given 5 centimeters. Meets a line through the center O at a point Q so that OQ will be 12 centimeter. Do you understand this, Manya?
Yes.
Yes. So a tangent PQ. I drew a circle. I drew a tangent. Of course, it is given that a tangent name is PQ and it is touching the circle at a point P. So that is why I wrote P there. Of a circle of radius 5 centimeter. Of course, radius is given 5 centimeter. And it also says it meets a line through the center O. The center name is given O at a point Q. So that OQ is 12 centimeters. So of course, you can understand if OQ is given 12 centimeter, you must be adding OQ. So you have to draw a line between O and Q to make it 12 centimeter. So it's a line segment, of course. And the question is, what is the length of PQ? This is what we have to figure out. Any idea, Manya, how can we solve this? Any guesses also?
No.
Yeah? No?
No.
Okay. But this will be very simple if I'll just give you one hint. Tell me one thing, Manya, that when we draw a tangent, okay, and when we have a radius, so what is the angle which is being formed here? This was the property, right? That the angle, that the radius is always perpendicular to the tangent. Yes or
Hmm.
no? Right? So can we not say that because this is the tangent, because this is the radius, so of course this is going to be 90 degree, right? And you can see, Manya, that there is a shape which is being formed. What is the shape which is being formed?
Interval.
A triangle, right? Is
Yes.
it not a right angle triangle?
Yes.
Yes, of course, it is a right angle triangle. So you'll write down in right angle triangle. Of course, that is very obvious that this will be 90 degree and that makes it a right angle triangle. So in right angle triangle, can you use one theorem here? What theorem can you use? As soon as we see a right angle triangle, Manya, the very first theorem that should come in our mind is what? Yes, Manya. In right angle triangle, which theorem we can use? Can we not use by Pythagoras theorem and Manya? Correct?
Yes.
By Pythagoras theorem, do you see one thing? That you have the length of the hypotenuse given, you have the length of the perpendicular given, and all you need to find is the length of the base. Do you agree, Anjali?
Yes.
Manya, right? Okay. So now tell me, what does the Pythagoras theorem say? What square is equal to the square of what plus the square of what?
B
Yeah.
B square equal
Okay. Was it not hypotenuse square equals Was it not that?
Perpendicular square
Plus base
plus
square.
height.
Plus base square, right? Perpendicular is the height only, Manya, right? So can we not
Yes,
write down that Pythagoras theorem, by Pythagoras theorem, of course, the hypotenuse square, that means OQ square, which is the hypotenuse, will be equal to the perpendicular square, which is OP, plus the base square, which is PQ. Do you understand this? If you want, you can also write down that point first, that by Pythagoras theorem, we know that hypotenuse square is equal to perpendicular square plus base square. But what is hypotenuse? OQ. What is perpendicular? OP. And what is base? PQ. And that is what we have to find out. Now, do you understand the question, Anya? See,
yes,
maybe you were thinking earlier that, oh, this is so difficult, I don't know how to solve it. But don't you think that this was a very simple question, Manya? Now, just because you have
yes.
understood the concept, now the question seems very simple. So now tell me, what is the length of OQ? Can you tell me the next step? You can definitely tell me. We have done these types of questions in trigonometry. Yes. What is OQ? In the triangle, what is OQ? Is it not 12? So is it not 12 square? Right?
Yes,
Right? Is equal to OP square. Tell me, what is the value of OP in the question?
5.
Very good. So this will become 5 square plus PQ square. You don't know. You have to find it, right? So
Yes.
Manya, this is very simple for you. Definitely you tell me what should I do in the next step. I'll just write. So come on, solve this.
Just a minute.
If you want, you can first solve the square. What is 12 square? I think
112.
112,
One
which
four four.
144, correct, is equal to 5 square.
25.
Very good. Plus PQ square. Now tell me the next step. We have to find out PQ, okay? So what is the next step?
25 will go in subtract with 144.
Correct. What is 144 minus 25? You can solve this and tell me the answer. PQ square will become. You're having no difficulty, right, Manya? Or you're having any difficulty, feel free. Okay, no worries at all. So you are able to subtract, right? 144 minus 25?
Yes,
Yes. Four, like, of course, 14 minus 5 is 9, 3 minus 2 is 1, and this is 0 only. Right? Sorry, this is 1 only, right? Because that has become 3. Okay, no doubt, right, Manya?
yes,
Are you getting 119 only?
yes.
Yes, okay, so the answer is 119. But this is PQ square. We want to find out PQ. So what do you think should be the next step? Will you not shift the square to the other side? So square will become what? 2119.
No, no.
Very good. So we have got the answer. PQ is equal to root over 119 centimeter. Now let's see, do we have this as an option or not? Do we have this as an option? Check. A, option, no, false. B, no. C, no. The correct answer is D. Do you agree?
Yes.
Yes, okay. Now let's go to the next question. The next question is the most simplest question of this exercise. Manya, draw a circle and the two lines parallel to a given line such that one is a tangent and the other a secant. It's very simple. I'll just tell you what is the question again. One second. Yes. So it says, Manya, draw a circle. So let's first draw a circle, right?
Yes.
Let me go a little down so that I'll have the space proper. Yes, perfect. So we have to first draw a circle. So let's draw a circle. So circle is this. Okay. And the two lines we have to draw and such that it should be parallel to a given line where one will be a tangent and other will be a secant. So don't you think that first you can draw a line which is of course going to be a tangent line because it will pass through the circle at only one point, and oh, okay, yeah, and you can draw one more line which will be parallel and which will also be the secant. So can you not draw a secant line also? Is that not a parallel line to the tangent line? Do you understand this? So we have drawn one secant line, we have drawn one tangent line, and of course they are parallel. Got it? Now it is not compulsory, Mana, that you have to draw only this way. You can also take a tangent here and then you can draw the parallel secant here. You can also take a tangent here and you can draw the parallel secant here. Are you understanding? That's it. This question was all about this much. I hope it is clear, right? So we have completed exercise 10.1 already. Do you have any doubt in this? Mana?
No.
No. So if there is no doubt, let's go to 10.2. Now for 10.2, we just need to use one theorem, like one or two theorem, and that's it. So let me first make you understand the very important theorem here only. You can see, Manya, that this is a circle, right?
Yes.
Correct. What are these two called?
Tangents.
Very good. These are two tangents. Now, do you notice that there is one point which is actually outside the circle, and through this point, we have drawn two tangents, this and this, right? Now, there is a theorem, Manya, which says that if you will take one point outside the circle, and through that point, if you draw two tangents on the circle, then the length from this point to one tangent, which is T1, will be exactly same, or you can say equal to the length of this point. This you can say line segment. Do you understand this? So what it simply says? It simply says that you are having a point outside the circle, you are having the two tangents, then the length of PT1, right? Because of course the name they have given
Yes.
as T1, so I'm taking T1. The length of PT1 will be same as the length of PT2. So suppose the length of PT1 is given 4 centimeter, then this will also become 4 centimeter. This is a theorem. Correct? Understood? Will you remember this theorem? Because through these theorems, we'll be doing a lot of questions. Okay. Okay. So this
Yes.
was our theorem. So see, it is written also. The length of the tangents drawn from an external point to a circle are equal, are always equal. Got it? So here what will be equal? The length of PQ will be equal to the length of PR. Got it, Manya? This is a
Yes.
theorem. Okay, this is a theorem. There is one more theorem, right? And that is, of course, you know that this is 90-degree and this is 90-degree. Do you agree? Because it is a radius and this is a tangent. So, of course, this is also going to be 90-degree and this is going to be 90-degree. But there is one more thing that you can notice, that you can draw, you can see here that we have drawn a line also, okay, from the center of the circle to that point P, which is outside the circle. Then the angle made here, this angle will be equal to this angle, whatever value it would be. It would be 30 degrees to 30 degree, okay, 60 degrees to 60 degree. And this angle will be equal to this angle. Will you remember this theorem? First
Yes.
was the length of the tangents are equal. That means PQ is equal to QR. Second is that, of course, because this is the radius and this is the tangent, the angle will be, sorry, here. The angle will be 90 degree. Oh, this is looking so weird. 1 second. Yeah. So this is the radius. So this will be 90 degree and this is also the radius, and on tangent it will be 90 degree. Next thing, two theorems, right? Third theorem is that the angle made here and here, that would be always same, and same at the center of the circle also. Okay, the angle made here is same as this angle. Now, why am I explaining you all these things right now? Because maybe in some questions we need them. Okay. So let us go to the next. Here, there is one theorem also, you can say, that prove that in two concentric circles. What is the meaning of concentric circle? The circles which are having the same center. Manya, do you understand the concentric circle meaning? You have drawn one circle here, you have drawn one circle here, but don't you think that for both the circle, the center is this only? Right?
Yes.
So such circles are called concentric circles. Not just two, but if you draw one, like you can say a center, and through that, can you not draw this circle? Through that center only, can you not draw another circle, another circle, another circle, and so many circles? For this circle also, the center is this only. For this circle also, the center is this only. For this circle also, the center is this only. For this circle also, the center is this only. Such circles are called concentric circles. Okay? Yes.
Yes.
Now, here it says that suppose you have two concentric circle, of course, C1 and C2. So prove that in two concentric circles, the chord of the larger circle, of course, you can see that in this circle, there is a chord which you can see, which is AB. That chord of a larger circle which touches the smaller circle, and of course you can notice that this chord is touching the smaller circle, is bisected at the point of contact. So it simply says that there is a theorem that if you have two concentric circles and if you'll have a chord of the larger circle which is touching the smaller circle at the point of contact, then the length of this will be equal to the length of this. These all are theorems, you just need to remember it. So the length of AP will be same as the length of PB. Okay, Manya? You don't need to understand all these proofs. You just need to remember these theorems so that you can use all of these things in your questions. Okay. Now, there is another third question which you don't need to do right now because, of course, it will take a lot of time to understand. It's very important that first we understand the basic concept. Okay. So, example questions, solutions are already given. Manya, go through the example questions on your own. If you feel like you're not understanding anything, you can ask me. Otherwise, if we will understand right now this question, it will take the entire class. So with keep it for you and solve it, and let me know in the next class whether you have got everything or not. Let's do exercise 10.2. How many oh, we have completed the circle chapter. We do not have any other exercise, right? We have only exercise 10.2 and that will be it. That's it. Okay, so in the next class, we'll be starting with a new topic. Today, let's just cover as many questions as possible. So in exercise 10.2, Manya, can you read the first question?
From a point Q, the length of the tangent of a circle is 24 centimeter and the distance of Q from the
I think I
center.
have to take a picture of this question. Yes, you read it. And then we'll be doing this question on the white note. Like on the OneNote, I'm sorry. Yeah. You read the question. From a point Q, the length of the tangent to a circle is 24 centimeter and the distance of Q from the center is 25 centimeter. What is the radius of the circle? It's a simple question. In fact, it's a very simple question. Let us first draw according to the question. So Manya, this time you will help me. What should I do? Okay. Yeah. Okay, I think I can make it little smaller. Otherwise, I'll not have the space. Okay, so it's very thin now. Will you be able to read the question?
Yes.
Okay, I think it will go now too far. No. No, 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 no. Okay, just a moment. Okay, I knew that this is going to happen. Anyway, so let's just draw it here once again. And yes. Okay, that's a huge problem. Okay, see, you can see that how weird it is looking. So let me just try once again to paste it. That question is very simple. Okay, I think I have to go back to that screen. Okay. Yes. Okay, finally it has come. So now you'll be able to read the question. So from a point Q, right, the length of, see, they're talking about the length of the tangent point Q. So don't you think that first we should be drawing a circle, Manya?
Yes.
Yes, we will be first drawing a circle. Also, you can notice that that diagram that is given on the screen is not for question number one, but for question number two. So don't get confused because, of course, it is for question number two. So from a point Q, let me draw a circle first. So we have a circle. There is a point Q. Let's take a point Q. The length of the tangent. Okay, so from a point Q, you have drawn a tangent, and the length of the tangent to a circle is 24 centimeter. Okay, that is given. So let's draw this. This is the tangent. Okay, and let's just write down this as a P. Okay, and this is given that the length of the tangent to a circle is given 24 centimeter, and the distance of Q from the center. So don't you think that this is the center, which let's name it as O? That distance from Q to the center is given 25 centimeter. So this is not 25 centimeter. Of course, this is 25 centimeter. The question is, sorry, one second. Okay, so we have to name it differently. This is not given 25 centimeter. You can notice from a point Q. Okay, so this is a point Q and not this. So from a point Q, there is a point Q. The length of the tangent to a circle is 24 centimeter. Now this is 24 centimeter. And the distance of Q from the center, this is given 25 centimeter. Okay, we have to find out the radius of the circle. Do you understand this? How I drew it, Manya?
Yes.
Yes. So first I started from the point of contact only, but it was not from the point of contact. It is saying from a point Q. It is not saying that that point was on the circle. So that was the mistake, right? It is just saying from a point Q, so it must be outside the circle. So from a point Q, the length of the tangent to a circle is 24 centimeter. And of course, the distance of Q from the center is given 25 centimeter. We have to find the radius of the circle. Don't you think, Mana, that this is similar question? What do you think we should be using here?
Pythagoras theorem.
Very good. Of course, you can name this as P, and you can see that this is the radius of a circle and this is the tangent. So this will be 90-degree, and that will make this triangle a right angle triangle. So what is a right angle triangle? Like, what does the theorem say? By Pythagoras theorem, come on, Manya, you can solve this completely on your own. So you tell me the steps, I'll write down. By Pythagoras theorem, hypotenuse square. Yes.
Uh, equal
Equals
p square
p square
plus b square.
Plus b square. Very good. Now tell me, what is hypotenuse here? OQ, OP, PQ, what is hypotenuse?
H.
Yeah, H is the hypotenuse, but in this figure, what is the hypotenuse? OP is the hypotenuse, OQ is the hypotenuse, or PQ is the hypotenuse?
OP.
But OP is the perpendicular. Manya, right? OP is the perpendicular, the straight line. The 90 degree is always the perpendicular, right? So don't you think OQ is the hypotenuse?
Yes.
So OQ square is equal to perpendicular. What is perpendicular? Of course, OP, which is nothing but your radius only, plus base square. Of course, base is PQ. Now tell me, what is OQ given? Okay, my screen got stopped. OQ was given in the question, right? Let me reshare the screen. Yes, so OQ square is equal to OP square plus PQ square, right? What is OQ given in this question? 25. So will it not be 25 square? Yes, is equal to OP square you don't know, which is also the radius that you have to find only, right? So OP is nothing, but we have to find out, plus PQ, the base, which is 24 square. Now, can you tell me quickly what is 25 square? Manya? Actually, you can use the formula also, but I'm not trying to make it complicated for you. You can just solve what is 25 square.
Just a second.
Yeah. So square and the square root you can remember till 50. And 25 square you can remember always, it is going to be 625. It will be 625, right? Equals OP square plus, what is 24 square? So if you find out the 24 square, how are you finding? 4 into 4, 16, and then 9. 4 into 2, 8. 2 into 2, 4. So it is 6, 5. So 576. Are you getting the same answer?
Yes.
It is 576. Next, Manya. What is the next step? Of course, we are going to shift 576 to the other side, right? So it will become 625 minus 576 equals OP square. You get it? Now, of course, we need to subtract this. So can you just subtract and tell me what is the answer you're getting? 15 minus 6 will be 9, right?
Yes.
Okay, 15 minus 6 is 9. What is 11 minus 7? 4. Correct? And then this is 0 only. So what answer have you got? 49. So 49 is equal to OP square. So what will be OP, Manya? Will it not be square root of 49? Now tell me, what is square root of 49? Which number will you multiply twice so that your answer would be 749? What is 2 square? 4. 3 square? 9. 4 square? 16. 5 square? 24. 5. 6 square? 36. What is 7 square?
49.
That is the answer. So OP is 7, not 7 square, because of course square root you have found. So it is 7 centimeters. So the options, which of course it was mentioned above, the answer will be 7. Let us do the next question also, Manya. For that, let me share. So the answer will be 7 centimeter, option A. You got it, Manya?
Yes.
Okay, now let us solve the next question, which is question number 2. This is also very simple, and for this, the diagram is also given. So it says in figure 10.11, if TP and TQ are the tangents, okay? TP and TQ are the tangents to a circle with the center O such that angle POQ is given 110 degree. You have to find the value of angle PTQ. This is very simple question. I'll tell you how can you do this. One thing, tell me, Manya, is it looking like a quadrilateral? Yes or no? This POQT, is it a quadrilateral?
Yes.
Why is it a quadrilateral? Because it has four sides, right? So it is just nothing but quadrilateral. Oh my God, my spelling is wrong. It's quadrilateral, right? So in this quadrilateral, angle O is given. Sorry, angle O. Angle O is given 110 degrees, right? Do you know what is angle P and angle Q? Manu? Don't you think that this is the radius and this is the tangent? So this will be 90? Yes or no? By
Yes.
theorem, right? So this is 90. Angle Q is also 90 because this is the radius and this is the tangent. So of course this has to be 90 only. So this is also 90. What do we have to find? We have to find angle T only. This is what we have to find because it says find angle PTQ. Find angle PTQ is same as finding angle T only. Okay. Let me erase this first. Do you understand that if you have to find out angle PTQ, it means you have to find out this angle, right? Which is nothing but your T only, correct, Manya? Now tell me, do you remember that I had explained that in a triangle, the sum of all the three angles of a triangle is 180 degree? Manya, you remember this?
No.
एक ट्राइंगल में जो तीनों एंगल का सम होता है वो 180 डिग्री होता है बट एक क्वाड्रिलेटरल में जो चारों एंगल का सम होता है डू यू नो व्हाट इज दैट दैट इज ऑलवेज इक्वल टू व्हाट 360 डिग्रीज ओके माने आपको ये याद रखना है एक ट्राइंगल में तीन एंगल का सम होता है फिक्स्ड 180 डिग्री और एक क्वाड्रिलेटरल में चारों एंगल्स के जो सम होते हैं वो होते हैं 360 डिग्रीज सो वो प्रॉपर्टी यूज करके कैन वी नॉट राइट डाउन दैट एंगल P प्लस एंगल O प्लस एंगल Q प्लस एंगल T will be equal to 360 degrees. This is a property of a quadrilateral, Manya. Are you understanding? ये मैंने क्यों लिखा बिकॉज ये एक प्रॉपर्टी है क्वाड्रिलेटरल का ऑलराइट ओके नाउ एंगल पी क्या है 90 डिग्री है क्यों 90 डिग्री है ऑफ कोर्स बिकॉज वो एक टैंजेंट वो जो पॉइंट ऑफ कांटेक्ट है वहां पे 90 डिग्री फॉर्म होता है राइट सो दैट इज 90 डिग्री प्लस एंगल ओ क्या है गिवन 110 so write down 110 plus angle Q क्या है of course 90 plus angle T क्या है we don't know we have to find out which is angle PTQ only so even if you write down just angle T it's the same thing okay the center angle they are talking about is equal to 360 now can you tell me quickly what is 90 plus 110 plus 90 this is so simple what is 110 plus 90 200 and what is 200 plus 90 290. So will it not be 290 plus angle T is equal to 360 degrees? Manya?
Yes.
So what will be the value of angle T? 360 minus like a linear equation, Manya. Yes, tell me. 360 as it is. 290 if you shift to the other side, will it not become minus 290?
Yes.
So what will be the value of angle T? What is 360 minus 290? That would be 70. So what's the answer?
70.
That's the answer, 70 degrees. So we have question number 1 and question number 2 also. We have finished exercise 10.1, complete question and exercise 10.2. first and second. Rest questions you can try doing on your own, Manya. In the next class, we'll be starting with a new topic. Okay. Yes, you
Okay.
can do the other questions on your own so that we can just do the other topics also, because we need to revise also what we have learned so far. All right.
Okay.
So, yes.